All right, well, hopefully you did well on your quiz. If you're watching on YouTube, make sure you get feedback on the quiz. Get the quiz back in some form or fashion before you take that exam. So that way I can make sure and you can make sure you're good to go with that math. All of the math on the exam will come from chapter 6 and what we've covered of chapter 7. So you will have a perpendicular vector problem on the exam tomorrow. We had a few of them just now on the quiz. So make sure you're good with that. Make sure I give you feedback so you know that everything's good to go, or you know what to correct before you try to take the exam. Also, you'll have chapter 6. So those formulas that have been on the bulletin board, those 5 formulas with acceleration, displacement time, initial final velocity, that will also be on the exam. No other math. But you will have terms from chapters 1 through 5. Let's see how many terms we can cover in the next 10 minutes. We're going to go rapid fire. You call out the answer. If there's a term you don't know, jot the term down real quick. Physics is the study of the interaction between two things, matter and energy. One of the reasons we study science in general is so that we can discover more about the world around us, so we can better ourselves. Also, we study nature because God reveals himself through his creation. We call this general revelation, because generally God reveals attributes about himself through nature. However, to really know who God is, to know who Jesus is, to really know his love more deeply, we need the Bible. The Bible is God's special revelation. We talked about fundamental quantities using SI units. What's the fundamental unit for length in the SI system? The meter. How about mass? Kilogram. Time. Seconds. Temperature. Kelvin. Amount of a substance. Moles. Electric current, which we'll get to later. Ampere. And then we won't actually even use this, so it won't be on the exam, but I'll ask it anyway. Luminous intensity. Candela. You don't have to write that down. That won't be on the exam. Let's see. Scientific notation we use constantly. Dimensional analysis we've used constantly. Sig figs we've used constantly. How close a measurement is to reality we call accuracy. The exactness or correctness of a measure is called accuracy. How consistent or how close to each other measurements are in a series of measurements is called precision. Error that is caused by a variety of factors that can't be eliminated or accounted for is called random error. But error that can be eliminated by using a better instrument or a better process is called systematic error. Using a faulty process or doing things incorrectly, that's systematic error. Anything that has mass and takes up space. Matter. All matter has a tendency to keep doing what it's doing. We call this inertia. All matter has a tendency to do what it's doing, to continue at a straight line at a constant speed unless acted upon by an outside force. If it's at rest, it tends to stay at rest unless acted upon by an outside force. How much matter is present in an object, or how much inertia an object possesses, either of those, is our definition for mass. The pull of gravity in an object's mass is called weight. And mass per unit volume is called mass per unit volume. Cram more mass into a small amount of space. Density. 4 states of matter. Solid, liquid, gas, plasma. Which of those has definite shape? Only the solid. Which does not have a definite volume? Gas. Solid or liquid has a definite volume, but not a definite shape. Gas doesn't even have a definite volume, which is why we have those gas laws, right, with volume changing, because volume can change for a gas only. And then plasma, remember, is just a highly ionized gas that typically exists at high temperatures. Basic building block of all matter, the atom. If you have something in which every atom is exactly the same, you have an element. What is a chemical combination of 2 or more atoms? 2 or more atoms chemically combined. Molecule. And if every molecule is the same throughout a substance, you have a compound. Good. Liquids and gases collectively are called fluids because they can flow. Within an atom, the number of protons gives that atom its atomic number. Number of protons is atomic number. number of protons and neutrons gives us the mass number. Good, since the mass of an atom comes from protons and neutrons. If you were to change the mass of an atom by changing the number of neutrons, without changing the number of protons, you've made change the number of neutrons, changing the mass, making it less stable. An isotope. Remember we talked about carbon-14 in our chapel video this last week, right? Carbon-14 dating, because it's inherently unstable. The negatively charged particles that go around the nucleus but are not within the nucleus, electrons. If you change the number of electrons, you change the charge of an atom. Ions. Positively charged, you've lost an electron. Cation. Negatively charged, you've added ions, or electrons. Anion. Good. Equation that shows the relationship between mass and energy. Albert Einstein, theory of relativity. E equals mc squared. We believe that protons and neutrons are made of little things called quarks. Two forces cause surface tension, capillarity. It's these attraction between different molecules. We call these two forces adhesion and cohesion. If the molecules are different kinds of molecules that attract, that's adhesion. The same kind of molecules attracting is called cohesion. Any push or pull on an object? Force measured in newtons. Force per unit area is called pressure measured in pascals. Liquid pressure primarily depends on depth, unless you have a confined liquid. Then somebody said in a confined liquid, pressure's everywhere the same. Pascal's principle. And one type of device uses a confined liquid to multiply force. Hydraulic device. You don't have to do the math with it. If an object is submerged into a liquid, there's an upward force that pushes on the object. Buoyant force. Now there's force pushing all over it, but there is an upward force called buoyant force. And the buoyant force is what helps some objects to float. Some things float, some things don't float. What makes the difference? Density determines whether or not the object floats. Specifically, that buoyant force will equal the weight of liquid that's displaced. Who said that? Archimedes. Liquid's resistance to flow because of adhesion and cohesion. Viscosity. Absence of air or other matter. Vacuum. An object whose surfaces are designed to provide lift. Airfoil. Guy who invented the first barometer. Torricelli, what's the barometer used for?
Pressure.
Measuring atmospheric pressure. Good. 3 measures of atmospheric pressure.
Torr.
How many torr? 760 torr. You started to say 1.0 atmospheres, or 1.013 E5 pascals. 1.013 E5 pascals. Volume and pressure. Boyle said that they are inversely. If you increase the pressure, you're going to decrease the volume. Volume temperature. Jacques Charles said they are directly related. You heat up the gas, it will expand. Any device that transports air or is driven by air pressure. Pneumatic device. Solids tend to keep their shape in some way or another. In general, we call this elasticity in general. Now, if they keep their shape by not being deformed, and if they allow deformation but they recover their shape immediately afterward, resilience. And those are both aspects of elasticity. Relative deformation of a solid. The deformation compared to the original size. Strain. Deformative force per unit area. Stress. Something that doesn't deform, it just breaks. Brittle. What type of stress causes stretching or compressing? Tensile. Which one causes bending?
Shear.
That's shear stress. The study of motion. Mechanics. Study of motion with disregard to what causes it. That's kinematics, or a kinematic approach to mechanics. Motion that results in a change of position. Enoch. Earth, heaven. He was
Translation.
translated. Translational motion. Translational motion along a straight line path.
Link. Rectangle.
Rectilinear along a curved path.
Curve.
For our purposes, we're assuming straight path. We're going to make it a straight path because all we care about is straight line distance from one point to another. Displacement. Any quantity that has magnitude but doesn't account for direction. Scalar. Distance per unit time is called distance traveled per unit time.
Acceleration.
Speed. Displacement per unit time, or speed in a particular direction. Velocity. Change in velocity per unit time.
Acceleration.
That's acceleration. Change in velocity per unit time, acceleration. Displacement per unit time is velocity. If an object is moving vertically and the only thing acting upon it is Earth's gravity, we would say the object is in
Free fall.
free fall. What is that value for G?
9.80 meters per second squared.
Good, and we assume if it's going down that's positive. If it's going up, gravity decelerates, so it would be a negative 9.8. If an object falls, then it gets faster and faster and faster and faster until eventually it goes splat. Well, except that air resistance at some point will cause the object to stop accelerating and just keep maintaining a set velocity that's really, really fast. What do we call that? Highest velocity an object can attain because of air resistance. Terminal velocity. And then, of course, we had what was just on the quiz, all those different kinds of vectors, solving collinear vectors, and of course, as I mentioned, we'll be on the exam solving perpendicular vectors. In 10 or 11 minutes, there's your terms. Study diligently for that exam in our next lesson. Have a wonderful rest of your day, and you are dismissed.